Distillation and reflux. Question 1. A perfume laboratory is investigating the molecules responsible for smell of some common flowers. The investigation suggests that the following two liquid compounds are important in characteristic smell of hyacinth flowers. We have been given two molecules, oxymanol, and the other one is cinamyl alcohol. A. Esterified dichromate solution can be used to distinguish between these two compounds. Only cinamyl alcohol can be oxidized using acid dichromate. Explain why this is so and describe any color changes you would expect to see. We know alcohol can be oxidized. Primary alcohol can be oxidized into aldehyde or carboxylic acid depending on the conditions using oxidizing agent. Secondary alcohol can be oxidized to ketones, and tertiary alcohol normally doesn't undergo oxidation. So let's look what type of alcohol we have been given. So we have a hydroxy group in both of them. Oxymanol is tertiary alcohol. As we can see, carbon, which is attached to hydroxy functional group, is directly attached to three other carbons or three alkyl groups, or we have R and we have whole of this as a R. So tertiary alcohols, they don't undergo oxidation, and cinamyl alcohol is primary alcohol because carbon, which is attached to hydroxy group, is directly attached to one alkyl group, or that carbon has two hydrogens. So cinamyl alcohol will undergo oxidation. So let's go back to the question. We can write down there will be a color change. Color change from orange to green. Because chromium 6 plus will get reduced to chromium 3 plus. Cinamyl alcohol is primary, hence oxidize. Cinamyl is tertiary alcohol, and tertiary alcohols don't oxidized. B. The products of oxidation of cinamyl alcohol by acid dichromate differ depending on the conditions. Two experiments are shown below. Name the appropriate boxes below. The technique used in each setup, the homologous series of the final product of oxidation. In this diagram, we can see this is a distillation apparatus, and so the technique used is called distillation. And distillation of primary alcohol using oxidizing agent produced aldehyde. So homologous series of product will be aldehyde. With partial oxidation. This setup is called reflux, and oxidation of primary alcohol using reflux produce carboxylic acid, so complete oxidation. So technique used is called reflux. Continuous boiling and condensation, and homologous series produce is carboxylic acid. Carboxylic acid. A student forgot to add anti-bumping granules while heating the reaction mixture during the oxidation of an alcohol. Describe what happens during the experiment and explain why anti-bumping granules should be used. Without granules, mixture may bump violently. Granules prevents pumping, splashing, and promote uniform boiling. Cinnamol and cinnamyl alcohols are both unsaturated molecules. We can see they have carbon-carbon double bond. Let's go back and have a look. In cinnamyl alcohol, we have one carbon-carbon double bond, while in cinnamol, we have two carbon-carbon double bond. Explain how you could use a solution of bromine water to show which of the molecules has the greater degree of unsaturation. So they both will react with bromine water. So we can take equal volume, use equal volume of cinnamol and cinnamyl alcohol to a fair test. Then we can add bromine water, bromine water will decolorize, bromine water will decolorize. More volume of bromine water decolorized cinnamol suggests more unsaturated cinnamol molecules. Mass spectrometry can also be used to distinguish between cinnamol and cinnamyl alcohol. The molecular ion peak in mass spectrum of cinnamyl is at m/z value 154. What mz value would represent the molecular ion peak in mass spectrum of cinnamyl alcohol? So let's go back and have a look at the structures to convert that into molecular formula. So we have 6 carbon in the ring, and we have 5 hydrogen in the ring. Then we have 1 carbon here. Then we have another carbon there, so 3. So we have 3 carbon outside the ring. 1, 2, and 2, 4, with the 4 hydrogen, and then we have 1 oxygen, and then we have another hydrogen there. If I add them together, we will have C9H10 and O. So C9H10O, C9H10O. So 12 times 9, plus we will have 1 times 10, plus we will have 16, and 108 plus 10 plus 16. So we will have m/z molecular ion peak at 134, and the ion that produce will be C9H10O positive. Write the skeletal formula of the organic product formed when reaction is stopped at distillation. So distillation will produce aldehyde. So our structure will looks like, so phenyl ring as it is, 2 carbons, and then we will have this. So it is aldehyde produced. When the reaction is carried out under reflux, carboxylic acid will be formed, and the skeletal formula of the product formed will be, so phenyl group as it is, and we will end up with carboxylic acid. So 1, 2, 3 carbons. Name the functional group present in each product. So in aldehyde, the functional group is carbonyl, and that is distillation. And functional group in carboxylic acid is called carboxyl, and that is in carboxylic acids, and that is product of reflux. 2. Alcohol can be used to prepare organic compounds with different functional groups. So we have diol can be oxidized to form dicarboxylic acid. State the reagents, conditions, and write the equation for this oxidation. In the equation, use square brackets or oxidizing agent. So the reagent we need is acid and potassium dichromate. Acid and potassium dichromate as a oxidizing agent. We can write it H plus Cr2O7 2 minus. Condition we need is reflux, and we can write down the overall equation. So we have a diol CH2 4 times OH plus oxidizing agent, and our product will be CH2 carboxylic on both sides, COOH, plus we will have water. We will produce 2 molecules of water. To balance it, we need 4 oxygens there. So this is the balanced chemical equation. How would the IR spectrum of oxidation products will differ from that of original alcohols? Use section 20 of the IB data booklet. So if we look in IB data booklet, so in alcohol, which is diol, there will be OH peak around 3200 to 3600 per centimeter. It will be strong and broad. In carboxylic acid, dicarboxylic acid, we will have C double bond O peak, and that will be around 1700 to 1750 per centimeter, and we will have OH peak around 2500 to 3000 per centimeter, and that will be very broad and strong. Figure below shows the apparatus that is used to separate mixture of liquid K and M using fractional distillation. Suggest labels that should be added to position S, T, and U in the figure below. Explain why fractional distillation is preferred to simple distillation to separate liquid K and M. Let's have a look. So S is fractionating column. So we can write down S is fractionating column, fractionating fractionating column. T is where the water out and U is where water in. So U water in, cold water in, and in condenser at position T, hot water out. Okay, so we can write down in T water out and U is water in. And explanation why we prefer fractional distillation. We use fractional distillation when the boiling point of two liquids are very close together. So liquid K and M are likely to have similar boiling point. Ethyl ethanoate can be made by reacting ethanol with ethanoic acid in the presence of concentrated sulfuric acid, so H2SO4 is used as a catalyst. Condensation or esterification is the name of this reaction. Method: a mixture of ethanol, ethanoic acid, and concentrated sulfuric acid with anti-bumping granules is heated under reflux for 10 minutes. Number 2, the apparatus is rearranged for distillation. The mixture is heated to collect liquid that distills between 70 to 85 degrees Celsius. Number 4, the distillate is placed in a separating funnel. Aqueous sodium carbonate is added and the stopper is placed in the funnel. The mixture is shaken, releasing the pressure as necessary. Number 5, the lower aqueous layer is removed and the upper organic layer is placed in a small conical flask. Number 6, anhydrous calcium chloride is added to the sample in the conical flask. The flask is shaken well and left for a few minutes. Number 7, the liquid from the flask is redistilled and the distillate is collected between 74 to 79 degrees Celsius. The reaction mixture is flammable. 1. Suggest how the reaction mixture should be heated in step 1. Because the mixture is highly flammable, so we can use electric heater, or we can use water bath, or we can use heat mantle. Figure shows how the student set up the apparatus for reflux in step 1. You should assume that the apparatus is clamped correctly. Identify 2 mistakes the student made in setting up the apparatus. So we're looking for 2 mistakes and state the problem caused by each mistake. So let's go back and have a look in the diagram. So we can see one mistake is there is stopper. There's a bung at the top of the condenser. So that should not be there. The problem, it will cause pressure will build up and stopper could be forced out. So that's one. The second mistake I can see straight away is water's going wrong way around. So water in should be, cold water always enter from the lower end and hot water leave from the upper end. So these are the 2 mistakes. Mistake 1 is there is a bung or stopper at the end of condenser. Problem, this can cause pressure build up, or we can say stopper could be forced Stopper could be forced out. Stopper could be forced out. Mistake 2. So water goes wrong way. Water goes the wrong way through the condenser. Water goes the wrong way through the condenser. So problem is water doesn't fill the condenser. So water doesn't fill the condenser. So condenser will not be cool enough. 3. Give a reason why 2 layers forms in the separating funnel. Suggest why ethanol ethanoate forms the upper layer. So the reason why 2 layers formed in separating funnel, because both liquids, they are immiscible. Ethyl ethanoate ester is immiscible in water. Suggestion: ethyl ethanoate is less dense than water, hence it flowed. 4. Suggest why anhydrous calcium chloride is added in step 6. So anhydrous calcium chloride is used as a drying agent, or we can say to absorb water.